Hello, everyone. It is a pleasure to be here today and to be a part of the infrastructure DevOps track during today's event. In this session, we want to present you an overview of the transformation that automotive industry is currently going through. We will show what ZF is doing, what challenges we were able to identify, how we approached them, how we adapted, and what benefits we were able to gain with the cloud revolution that is happening right now. All that in order to make public roads safer. My name is Tomasz Olek. I'm a software team supervisor at our engineering center in Łódź. I have 6 years of software development experience and in leading software teams that develop tools for validation of our AD and ADAS systems. But first and foremost, I am a huge petrol head.
Hello, everyone. My name is Łukasz Fras. I'm the software team supervisor at ZF. I have started my automotive journey in 2015. I have total 8 years of experience. I am responsible for leading the software teams at ZF. I'm additionally a trainer for dedicated advanced software for bus analysis and also programming in Python, which I'm a really big fan of. Together with Tomasz, we are a part of the ADAS validation within the electronics at ZF. We are providing the tools that helping our engineer for checking the software and the hardware that is produced by us. On one hand, people can say that we have a good involvement into the tools and the overall features that are later on available for the commercial usage for end customer.
For a start, to maintain some level of engagement from our audience, I would like to ask you a question. Please raise your hand if you have ever heard of the company ZF. Okay. Have you heard of any specific products that we develop? Transmissions. Yes, that is a very good answer. I will refer to that in a bit. But for those who are not so familiar with us, don't worry, we have prepared a quick recap. ZF is a global supplier of mainly automotive components for both passenger and commercial vehicles. We think that our most known and flagship products are our automated transmissions like 8 or 9 HP that are currently available in dozens of currently available models on the market. But ZF is much more than that. We develop e-mobility solutions, passive and active safety systems, autonomous vehicles, and mechanical components. Under our wings, we have several brands like Zax, TRW, Lemforder, Wapco, and Boge that offer a wide portfolio of components for OEM customers and workshops. We are present in almost all segments of the automotive industry, and we continuously grow since year 1915, so for quite a long time already. But recent years have been especially fascinating due to the rapid growth of alternative types of drivetrains, increasing level of autonomy, very competitive market, and a very demanding environment.
So one could say, what the hell we are doing here at one of the biggest IT event in Poland? ZF is one of the leaders in terms of providing the cameras for ADAS. As you can see on this slide, we are the first supplier to manufacture who reached 10 million of cameras in one single year, 2022. Totally, since 2008, we have reached 50 million of cameras. So it's a huge numbers. We are responsible not only for cameras, we are also responsible for radars. We are providing, of course, 2 solutions at once, of course, if our clients needs. We are calling that such systems like fusion systems. Our market grew by 33%, and we have reached in last year 2.4 billion in market on sales. We are talking about the cameras that are able to see the road, see the traffic signs, traffic lights, recognize the object, perceive the lanes, and even take about the situation which is on the road.
To gain the current position that we have right now, it required a lot of both hardware and software development. In recent years, the significance of cloud computing skyrocketed due to the advancing complexity of ADAS systems. We, as ZF, had to completely rethink our approach, our IT processes, and how we develop products. Now we are ready to share some of those experiences with you and show you how Microsoft Azure made it possible for us. For a start, to give you some idea of complexity growth in recent years, we show you this diagram that many of you may be already familiar with. It became very popular in recent years. It shows the classification of assistance systems based on their capabilities, beginning with simple ones at level 1, systems like ACC, adaptive cruise control, that can influence only one factor of driving the car, through more advanced ones at level 2, like highway co-pilot or traffic jam assist, that can influence at least 2 factors of drive, through more advanced ones on level 3, right up to level 5, where the driver is not needed at all times. As ZF, we started our journey in ADAS in the year 2002 with the introduction of our first radar to the market that was able to provide functionality of ACC in luxurious executive limousines. Our portfolio right now in our division mainly focuses on levels at the edge of 2 and 3, a so-called L2+. But in our portfolio, ZF also has systems at level 4 for autonomous transportation of people inside cities. Level 5 right now is more a great dream for the future rather than a realistic objective for next 2 or 3 years, but who knows how things will advance.
To quickly understand the things that we are referring to, here is the quick demonstration of one of the advanced functions, which is called autonomous emergency braking. Our car over here is equipped with the camera, front lidar, and side radars. As you can see on this video, this truck will change the lane. The car will automatically check the situation on the left, on the right, and in front of it. We'll choose the empty line to safely stop the car. On another video, we've got a real scenario in our vehicle. This is a test that is performed by our validation engineer. The child is passing the street and system automatically stopped the car. We've got something more, which Tomasz mentioned. We are talking about the level number 4. This is the traditional public transportation, the situation when you can order the vehicle on demand. This one, which you can see on the screen, is equipped with the advanced complex solution, ADAS solution, with the camera, lidar, and radars that have 360 perception of the view. Such a concept is now visible on the screen in the real life. It's available in southern part of Netherlands in one of the biggest business parks in the city of Rivium. This is a true alternative for privately owned cars. Recently, at the CES Las Vegas this year, we have shown our second generation vehicle. It is better, more complex, can take more passengers, can pass greater distance, and even greater speed. It's a new way of autonomous mobility. To see the difference between those two solutions, here is the slide which is presenting you the situation when you have first generation of the vehicle, which can be used only for segregated lanes, and another one which is the second generation vehicle, which can be used with mixed traffic, can be connected to the other vehicles, and can be a really true alternative for transportation like buses or train.
Since 2002, we as a company took many steps to be where we are now. We have been consistently developing solutions for seeing the environment around vehicles, percepting it, understanding, and reacting accordingly. As already mentioned, we started our journey with our AC-10 radar that had a range of 150 meters and could reduce vehicle speed to 30 kilometers per hour. Since then, we introduced several generations of our radar technology into the market, with our latest addition being the 4D imaging radar that can measure environment in 4 dimensions: range, azimuth, elevation, and velocity. Has viewing range of 350 meters, of course can bring vehicle to a full stop, and has level 4 capabilities. As Łukasz previously mentioned, we also develop other types of sensors, these being cameras. Our first camera came to the market in 2008. It was a T-cam. It could provide the functionality of lane keeping assistance. Since 2008, we've brought newer generations of our smart cameras, with our latest smart camera 6 hitting the market next year. Those cameras can perceive environment, detect objects such as vehicles, pedestrians, stop lanes, traffic lights, oncoming lights of other vehicles, and can act as standalone sensors, as well as perform the fusion of data from other sensors, and then provide a synthesized output to the car. While we are at fusing data, for managing data from multiple sensors, for processing images, point clouds, or other perception data, we have to provide a significant amount of computational power. And for that, we developed platforms like ProAI or HPC, that is high performance computer, that are capable of managing this amount of data and providing stable and secure steering to the car.
It is worth to mention that tectonic shift in our vehicle architecture is making right now. As you can see, the distributed components where they're responsible for many components at the architecture has been abandoned to the situation when we have much more simpler solution. We are going to the domain approach where one ECU can be responsible for ADAS features, motion control, and entertainment. It seems that the OEMs will go even further for the zonal approach, which is over here. It seems that we will have fewer units that will be responsible for the components in our car. It is, of course, a reduce on the hardware units, but it sets a really good challenge, a big challenge for the software. To stay on top of that, we need to provide such solutions like ProAI, which can run our code and stay connected to the cloud by all the time. Let's now talk about the numbers. Here is the slide which is presenting you amount of the data which is generated by the one single field operation test.
We perform such an FOT at the initial phase of every project. For example, when we prepare an application project for OEM customer. We record test data with early samples of our devices together with reference sensors and metadata through our logging system. Of course, we do that with vehicles that have an open loop setup, so where camera or radar cannot influence the actual behavior of the car on the road. It is an early sample. You need to keep that in mind. For nearly every new project, we need a fleet of 20 to 30 test vehicles spread around the whole planet and covering a total mileage of 500,000 up to 1 million kilometers to assure that we have enough raw data for further testing and validation of our product. In a test setup that can generate 6 gigabytes of data, that can result in up to 10 petabytes of total raw data that we also have to store somewhere. On top of that, open loop data is not enough. We then have to further reprocess, resimulate data with newer software versions, and that multiplies the total amount of storage that we need by far. To better explain you what is capable of generating 6 gigs of data, here we present you the setup of our exemplary test vehicle.
As you can see on the screen, we've got imaging radar and the smart camera. That are two products that will be later on available for end customer. Such a solution is called fusion system. To be objective to all the data which is captured by the sensors and validate it in the proper way, we need to have additional plenty other sensors. What kind of sensors are there? We've got front lidar, reference camera, 360 lidar, labeling camera, real lidar, military class GPS and IMU. All the data which is captured by all the additional sensors are saved on the SSD drives which are all connected in our car trunk. Unfortunately, we do not have such a mobile connection around the world everywhere to transfer the data automatically to the cloud. This is the challenge for us, which we need to fix out.
Over time, we approached this challenge in different ways depending on technical possibilities that were available at the time. Few years back, while we had a centralized data lake, data recorded all over the world had to be delivered to this one central place. We had to perform a lot of shipping, and I mean a lot. Bringing all the hard drives to one central storage, mounting them, connecting, copying its contents to our server rooms took a lot of costs and time. Don't imagine the costs of logistics that stood behind all that. Right now, thanks to our cooperation with Microsoft, we can have such upload hubs spread around the world. After performing test drives in a given region, we only need to provide disks to those upload hubs, and data is almost immediately available on our storage accounts for further processing. Our dream scenario for the future is, of course, that we'll have stable and fast connection with the cloud right in our test vehicles so that we can access test data as we ride.
Years ago, the requirements in terms of the infrastructure was not that big as it is now. ADAS functions were less complex. Our fleets of cars was smaller. We have generated less amount of data. Of course, we have resimulated fewer only simulations. Fewer people were also involved into the development. Many operation has been performed on self-hosted equipment. Back in the days, we realized, together with increase of NCAP and other safety requirements, that ADAS functions are developed better and better in more complex way. It means that we need to store more data. We are generating more data. But we are not only talking about the data, and the change was not only forced by amount of the data, by all the sensors that are later on available for the customer. We are also talking about the additional data which is captured by our sensors. We need to invest for more accurate and high-resolution sensors that will capture all the data to have proper analysis for later on resimulation and certain KPIs. We all together know that thanks to the Azure, we can order and pay as we go, so only for those needs which we already are requesting for. So if we need more computing power, more VMs, it is available for us on the go.
How the whole active safety validation process looks like is the next thing that we want to show you. We split it into several quality gates. At the beginning, we perform a data collection we do an aforementioned FOT, but that is not enough. Each ADAS function requires its own separate catalog of scenes that we record additionally on test tracks and that are compliant with NCAP requirements. After that, together with FOT data, data upload needs to happen. We deliver the data to upload hubs and put them into the storage. In here, we can provide an initial check of data quality on its format and integrity. In step 3, we perform data normalization and we store the input in a normalized form into our databases. This step is required because different sensors can have different data models, and we need to unify that for further processing. In here, we can provide a compliance report on the performance of sensor during the drive. Next up, in step 4, quality gate 4, we perform reprocessing. It allows us to compare how the sensor performed at the beginning of its development and then how it advanced through next versions of software. HIL concept, hardware in the loop, assumes that we have a physical device in our laboratory into which we inject raw data and observe how it behaves with an uploaded firmware. In SIL concept, software in the loop, we don't use any laboratory equipment and perform whole simulation in a purely virtual environment. In parallel to those, a two-step data annotation process is happening. We use stuff recorded by our reference sensor and generate an independent labeling out of it that can then serve as ground truth for KPI calculation, which is step number 7, and is about checking the performance and accuracy of our sensors against the ground truth. We can calculate KPIs and prepare reports for our customers in the form of static reports or dynamic dashboards, depending on the customer. This step, together with data reprocessing, is usually performed multiple times in the life cycle of a project, as we develop several versions of software and we need to test it all properly. So the performance is usually increasing with time.
Thanks to our strategic partnership together with Microsoft, we can nearly run all our pipeline within Azure cloud environment. As you can see on the slide, we are using most of the features natively, but some of them are run as a service on virtual machines. We utilize the blob storages for archiving raw data and normalize extracts in several types of the databases. We use the OpenShift as our platform of choice for apps containers to scaling them on demand. Together with data storage and tools like Tableau, we are able to widely analyze the big data and, of course, generate some dashboards. Application insights are used for checking the performance and health of our processes. IoT functions come handy into the connection our vehicle to the cloud. We can rapidly change the situation on the road, we can update the firmware, and even check the telemetry of the vehicles.
Now let's briefly focus on one specific use case. As you can see, this is a simplified extract of the process that we were showing before. I already said that with every new software version, we need to provide a performance report. In here, we focus on just one function, AEB, Autonomous Emergency Braking. For this function, requirements state that we have to process at least 200,000 kilometers of input data in order to test it properly. To perform such performance analysis in less than a week, we had to engage an OpenShift cluster consisting of 100 virtual machines, each of which had 32-core CPU, and 256 gigabytes of RAM. That allowed us to get a synthesized event data output at 2.4 terabytes size, which accounted for just 0.16% of total input data. This is quite a significant reduction. And remember, this flow needs to be repeated multiple times for every new software version and for every function. And ADAS system can consist between 5 up to even 10 functions.
So what we have gained after switching to the cloud infrastructure? First and most important thing is the scalability of the solutions on demand. When we are talking about the cloud solution, we are trying to make it possible to gain as much advantages in terms of the technical and financial aspects. When we are close to the starting of production of our product, we need to more computing power. We need that to make some simulation, to generate some reports on demand. It is a really, really big and big amount of data for analysis. Of course, thanks to the Azure, we are able to do so. We sometimes push the binaries of Microsoft database centers. And of course, if we are talking about the pushing the binaries, we have strategic partnerships that help us to do so.
We remain flexible about the location and performance of our resources. For more demanding processes, we can ask for more efficient infrastructure, and for simple stuff, we can stick with less CPU power, less memory, and less network bandwidth. We don't have to worry so much about the reliability of our infrastructure. Cloud provider is here to take care about the whole maintenance of the infrastructure and assuring minimal downtimes on our side. We can significantly reduce IT efforts on our side. We can reassign people to engineering tasks and keep only small teams that only monitor our processes. We don't have to maintain infrastructure on our own, so our local server rooms can be reduced. We don't have to buy as many powerful machines on our own. We don't have to worry about keeping them powered, running, even if they remain idle at some times. All that can be reduced in favor of infrastructure being served as a service by Microsoft. Those things translate directly into cost savings. We are built based on actual usage of infrastructure. We can look into forecasts based on that, prepare better planning, and we can also offer more accurate quotation to our customers. IT costs are also reduced. We host minimal equipment on our own and focus more on actual engineering work. Capital expenses are limited in favor of operational expenses that are much easier to process within a company.
Not convinced yet? We have additional benefits and savings. Thanks to this architecture, which is available in cloud, we can easier way cooperate with external companies. We don't need to give them whole internal access to share some apps, which is a really convenient way to cooperation. It is also worth to mention that we need to have adequate level of the security for sensitive data that is also available in the cloud. It is also worth to mention that we have additional statistics and telemetry for the vehicles and laboratory stations. In-house development, which is over here visible on the car, is a test run, which is one of the route that was passed by our vehicle.
In addition to telemetry being available at all times, we also have several different solutions for checking the performance of our sensors and algorithms. One of those solutions is our software as a service product, ZF Visual, an application that is widely used in our company for checking the data live in the car during the drive, later on offline with locally stored measurements, and also while streaming the data directly from the cloud. This application is also used for development of level 4 autonomy systems. Okay, so now let's think about what lies ahead of us. Unfortunately, our crystal ball is currently under maintenance, but despite that, we have quite a good idea of what's next. We need to keep optimizing our costs in order to remain competitive. We plan to do that with further generalization of our processes and shifting the mindset from projects to products. We are aware that with phasing out legacy projects, we have to reduce our local equipment even more and shift towards virtual resimulations. That is why our engineers are already working on better models and SEAL programs. In order to remain with as many customers as possible, we have to maintain compatibility with other cloud platforms for cases when our customers use other cloud provider.
We already mentioned about the problems that we have at the moment to transfer the data directly from the vehicle because of the mobile network, which is not available everywhere. So we are looking forward to improve that and develop the solution that will allow us such things. It is worth to mention that we are only talking about the solution for test vehicle, not regular cars that are later on available for the dealerships, for the end customer.
We hope that we are able to convince you about the significance of cloud computing in the development of AD and ADAS systems. Without our cooperation with Microsoft, it would be much harder to stay on top of the game. We showed you that the transformation that we had to go through allows us to offer next-generation mobility solutions right now, today, and look with confidence into the future.
Thank you very much for joining us today for today's session. If you have any question, or maybe you would like to have some better insights into our cloud infrastructures, our cloud architects are available in our stand and are happy to speak with you. Thank you very much.
Thank you very much.